Hello everyone, today I want to make a little news video about the recent events around SpaceX and the widely reported Thai cave rescue from a slightly more technical perspective. First of all, yes, it is another event-based report. I'm still a bit too busy to do regular videos about general physics. More frequently, the project I'm working on is coming along a bit slower than expected, but it is coming along. However, I can't go much further into detail on that. If I would, I'd have to mark this video as a product placement, and then I'd have to explain that, and it would all get more complicated, and I really just want to make a quick explanation on these current events, but soon. Now, first of all, I would like to focus on the technical aspects, but I will also roughly report the overall situation, which has been confused a bit recently. So even though it's already widely reported on, I will do a quick recap of that. Now, it started chronologically with a children's football team from Thailand, including their coach, visiting a cave for recreational activities. They were just going to visit a cave for a little while. It was supposed to be relatively safe. Then a strong rainfall hit, flooding started, and the cave passage as well started to flood from below, essentially, trapping them in a bubble of air in the end of the cave, while their way back to the entrance or exit of the cave was blocked off by several passages being flooded. A catastrophic situation. Some of the children couldn't swim, and even if they did, those were some relatively long passages. Cave diving is always really dangerous. There were some very narrow passages. You could get stuck there, you could get injured, and generally some of the dives are just too long to hold your breath. So there was no real way of them just leaving without help. However, someone knew they were in there, and so rescue operations started classically with Navy SEAL divers going into the caves and rescuing the boys out one by one using a breathing mask and oxygen tanks, and basically guiding them and pulling them and dragging them and helping them through these caves and leading them out one by one. And while the operations were working and boys were being rescued from the cave successfully, the operations weren't going perfectly smooth. One diver actually died in the cave, which is of course a severe tragedy, but at least one by one children were getting rescued. They were, however, under severe time pressure. The caves were flooding further. The air in the part of the cave that the soccer team was trapped in was very limited, and equipment and diving techniques only made for slow progress. At that point, Elon Musk, who on this channel we all know as the SpaceX guy, but also the Boring Company guy, made some loose suggestions on Twitter for how this situation could hypothetically be solved in a slightly more innovative and high-tech way. At this point, planning to use an inflatable tube that would then fit against the inside of the cave and make for a complete passage tunnel filled with air, so you could just walk out of the cave. He then got into contact with the rescue teams and started lending his expertise and communicating back with their knowledge. He slightly revised his plan to be faster to realize. Rescue operations continued, but at the same time Elon Musk started building a tiny submarine out of spare parts lying around at SpaceX for the Falcon 9 rockets. This is what I'll mostly be talking about here. Then SpaceX did deliver that submarine to Thailand, and Elon Musk actually visited the cave him very self. Luckily, rescue operations did progress very smoothly, and at that point they didn't have the time to properly integrate the submarine into these operations, but had anything further gone wrong, it would have been there as an emergency. Now, they did manage to rescue all the children without that, but had that taken longer or gone wrong, the submarine would have been there as a backup option, and is now being kept around so it might be used in case of any later unrelated different emergencies. So it didn't actually get used, but there is test footage, and of course the entire effort is quite noble, and while Elon Musk has already been praised for this a lot, yeah, he did do a great job. Of course, so did the divers who actually ended up rescuing the children, and yes, tragically one of them died in the operation. What I'd like to talk about in detail is how that submarine actually works and what it's made out of and why, since this was also met with a bit of confusion and it's more of my field of expertise. The submarine was mostly made of a repurposed part of a Falcon 9 rocket, the liquid oxygen transfer tube, or one segment of that transfer tube. Now first of all, let's put that into context. In its original function, where on the Falcon 9 is that and what does it do? Now, it's not the oxygen tank itself. That is a lot bigger. I mean, you've seen the test footage and it has to fit through narrow spaces. It's a really narrow, tiny submarine. And the SpaceX fuel tanks, even though the Falcon 9 is a relatively slim rocket, are a lot bigger. You can see on a photo that you can easily stand inside. It's 3-meter diameter. The liquid oxygen transfer tube is now just the line that transports the liquid oxygen from the liquid oxygen tank to the engines. And that is much more narrow, and it has some special properties due to the relatively special design of the Falcon 9 first stage. The thing is, in the Falcon 9, the oxygen transfer line doesn't go around the fuel tank within the rocket's fuselage, but actually goes straight through the fuel tank. You can see in a diagram that the fuel tank and the oxygen tank are actually one and the same. So there's basically one big pressure vessel, and the fuel, the slightly chilled RP1 kerosene, and the oxygen, the cryogenic liquid oxygen, are stored in different sections of that tank under different temperatures and different pressure, which is why there is a common bulkhead in between them, which is basically a extra wall inside that tank that separates these two tanks within one tank. And within that bulkhead there's a small hole, and that hole connects to a tube that goes through the lower tank to the engines at the bottom, so there are no fuel lines besides the tank, making the rocket unnecessarily wide. A rather elegant and lightweight design, though it has both advantages and disadvantages. The common bulkhead has caused a failure once, though that issue is mostly solved by now. The tube itself, however, is very flight-proven and reliable. Now, the oxygen tank is on top of the kerosene tank in the Falcon 9, as well as in many other liquid-fueled rockets using kerosene. So the tube going through the lower half tank is transferring oxygen. That's why it's called the liquid oxygen transfer tube. This tube is actually relatively narrow, as you can see in an image of someone inspecting it during the Falcon 9 assembly, as well as, of course, the test footage of the submarine, which is mainly made out of one section of that tube and thus has the same diameter. You can also see the entrance to that tube in liquid oxygen tank footage from rocket launches. There are cameras within the liquid oxygen tank to observe the behavior of liquid oxygen. Liquid oxygen during a rocket launch and in zero gravity and during acceleration and vibration behaves somewhat weirdly and complicatedly, and so it's interesting to study and important to study if you want to improve rocket designs and keep them safe. And you can find footage of that camera inside the liquid oxygen tank. It's attached to the upper side of the oxygen tank and filming down through the oxygen tank. The liquid oxygen itself is mostly transparent-ish, and so you can see the bottom of the liquid oxygen tank as well as the tube leading down, which is opened by valve when liquid oxygen is needed, and then it basically drains down there, although there are other mechanisms, of course, since it also has to work in 0G. There is a helium system in the Falcon 9 which has several purposes, but among others to provide pressure to pressurize the oxygen tank when oxygen is used up, so the oxygen is still kept liquid and pushed down through that tube. Now this already gives us some interesting properties for this tube that are required for the design of this tube and thus present in its segments and can be used if you repurpose these segments as a submarine. For once, it's not just an open tube leading through the fuselage of a rocket, it actually leads through the kerosene tank, which is cooled kerosene to make it more dense, so it's already designed for cold liquid slushing about around it. It is already designed for actual outside forces, not just for pure pressure, but also to handle forces coming in from the outside irregularly. So unlike some other possible pressure vessel designs, it won't just pop like a balloon. It's relatively practical to handle. And it's not a pure aluminum tube either. It also contains insulation, since the liquid oxygen is kept at a much colder temperature than the kerosene. Both the common bulkhead between the two fuel tank parts and the liquid oxygen transfer tube have to be insulated. Otherwise, when leading liquid oxygen down the transfer tube, the low temperature would just go through the aluminum walls. Aluminum is very thermally conductive, and since it's thermally conductive, you'd have the risk of both ice building up. Kerosene might freeze around that transfer tube, which is below kerosene's freezing point, and you might have ice buildup, which could be catastrophic. And at the same time, the high temperature outside could lead to the oxygen inside vaporizing or building up more pressure than it should. So the tube is already insulated, which is kind of useful if you want to safely transport people through very cold water. Now, what Musk and his team did was to take two ends for tubes that were modified to fit onto this tube, so they could close it off at both ends. These would be kept in place with several bolts, but these bolts can be rather quickly removed, so people can enter and exit, and then you can screw it shut and transport it and screw it open rather quickly again. At the same time, it's still sealed. And to one of these end caps they added holes and adapters so a normal diving apparatus could be attached to it. They then added a few struts so the diving apparatus could basically be attached to the side of the submarine and be plugged into that end cap, so you have oxygen inside. The submarine could easily transport a child, and less easily, but would still be capable of transporting an adult. At the same time, it would be lightweight enough to get carried around by two people on land and small enough to fit through narrow spaces. It would be pulled around underwater by divers, but provide a safe and easy-to-use shield around any person with no diving experience being rescued. It was tested out by divers in the US within a pool. They could both easily carry it around on land and maneuver and pull it around underwater. They tried out maneuvering it through narrow spaces, simulated by a simple wiring to indicate where the space ends, but they still proved that they could transport it through narrow cave passages if needed, and divers were actually transported inside it to demonstrate that it could carry humans rather safely. Now, these divers do have diving experience for the case of emergency, but they didn't actually need it or use it since the submarine worked. So it was actually quite a fitting and clever idea to use this part, and even though rescue operations luckily went smooth enough for the submarine not to be used or needed, it was still good to have a backup plan, and now they have a submarine lying around in case they need it for some other emergency. Actual Falcon 9 operation has not been significantly pushed back or obstructed by this side project. Either way, I hope you enjoyed this little slightly more technical overview over these recent news that have been going around quite a bit, so everyone probably already heard of the general story, but I wanted to provide a bit more rocket science and technology related context for this part. I'll hopefully soon get around to making more general physics related explanations again soon. If you have any questions, I'm always open for requests, and as always, thanks for watching.